Here now see the table here, tabular column is there. In that we are talking about the particles, their symbols, their charge, their relative charge, mass and in units, mass in kg and mass in atomic mass units and approximate mass. So in this table we will get a clear picture of all three subatomic particles. When atom is designed, it is made up of these three particles. The nucleus, which will have positively charged protons, neutral neutrons, and around the nucleus there will be negatively charged particles which are moving particles. See, this proton and neutron doesn't move, nucleus is present in the center. So the mobile particles which are very light in a mass and charge ratio, and that particles are negatively charged, electrons are moving. Now let's see here. So electrons symbol is taken as generally E, and absolute charge is minus 1.6022 into 10 power minus 19 coulomb. It will be taken, the unit can be taken as coulomb here. Okay, here minus charge indicates electrons are negatively charged particles. Okay, the relative charge is -1. And what is the mass of the electron? We have already calculated the mass by charge by mass ratio from the Mulliken oil drop experiment yesterday's class, previous class. So 9.10939 into 10 power minus 31 will be mass per kg. Okay, next is mass per unit. When we calculate, when we convert it to mass per unit, 0.00054 will be taken as mass per unit. So approximate mass, if we talk, it is a very light particle, approximate mass is 0. The next we are talking proton. Proton symbol is P. What will be the absolute charge in coulombs? It is present plus 1.6022 into 10 power minus 19 coulombs. Okay, coulomb will be the unit for charge here. So here positive sign indicates protons are positively charged particles. We can take relative charge also +1. Then what is the mass per kg? You can see the difference here and here, 1.67262 into 10 power minus 27. Okay, so the difference comparison between neutron and proton also you can see here, and mass per unit is taken as 1.00727. Now approximate mass in units for electron is very light particle, so it is 0. It is for in case of proton it is 1. So in all these two cases of proton and neutron, see, neutron doesn't have any charge but mass is more than proton present here. Okay, so we can see here, you can see this comparison to both. The neutron's mass is little more than the protons. Okay, but charge, if we say there is no charge present, it is neutral, so 0 we are writing. So symbol is N for neutron, and absolute charge is 0 because these are neutral, electrically neutral particle. Again, electrically neutral means what? When the number of positive and number of negative are getting cancelled by each other, it called electrically neutral. Or in electric field also we can say they does not show deviation towards positive or negative plate. So that kind of particles are only neutral particles. Okay, so mass per kg will be taken 1.67493 into 10 power minus 27. So is it clear the comparison between these two masses? This is the mass of proton, this is the mass of neutron. We have said mass of neutron doesn't have any charge, but mass of neutron is little more than the proton. Okay, and if we say mass per unit also, you can see it is little more per unit also. This is 1.00727 and this is 1.00867. Okay, so approximate mass per unit is 1 in this case. So I think this table is giving a clear idea about all the three subatomic particles. The fundamental particles also we call it as commonly like electron, proton and neutron. Okay, so the experiment mentioned, suggested that Dalton's indivisible atom is composed of subatomic particle carrying positive and negative charges. Positive charge is called proton, negative charge is called electron. Okay, atomic models were proposed to explain the distribution of these charged particles in an atom. Although some of these models were not able to explain the stability of atom, two of these models proposed by J.J. Thomson and Ernst Rutherford. Okay.